So they keep trying and they start screaming at the microphonium. And I have to give them the report, well, you sound like a mother flea calling its young, come back when you can fix it. The other thing is, the audio sections, and particularly with the ICOM gear, is very, very restrictive in terms of values of coupling capacitors and other things along the way that kill the low end and also kill the high end. And speaking of which, you'll look at other rice boxes, the Kenmore line. Now, they sort of have their act together. The audio out of most of the Kenmore product is clean and smooth, but brick walls at 3100. So that's just the way the radio is. It's whether or not they're using filtering, like a crystal filter, or maybe they're moving more and more to the DSP-based model as ICOM has. In theory, DSP technology can yield very high quality, sideband high quality AM or whatever. But with the slow bit rate of the ICOM equipment's DSP technology, the high-end audio response, brick walls again, at about 3 kilohertz. It's not enough. And then you ask yourselves, how wide a frequency response is really necessary for good quality AM. I'm talking high fidelity speech. That's about 5 kilohertz. So total bandwidth, 10 kilohertz. A number of our transmitters go well over 5. Mine does, but it's how much speech energy is actually there. How much of the time will you actually have high frequency components that are 10, 15 kilohertz away? Very little actually. But at nighttime, if you know you have a big signal, it would behoove you to have some kind of bandpass filtering to roll the highs off at 5,000, only for nighttime operation. But then again, how many of us have receivers that are much wider than 10 kilohertz to hear the good high end in the first place? So with a rice box at 3 kilohertz of audio, you're on the edge. You're right on the edge, although some other rice boxes, we go back in time in the 80s when you had the Yaesu 757GX and the ICOM had the 735. Now if you look at both of those radios, went on AM, there was no bandpass filter. The 757GX had a 2-pole, maybe it was a 3-pole pi section filter between the second audio stage, which was a voltage gain stage, and the third stage, which was a emitter follower that drove the balance modulator. So the high end would just brick wall and die. But there was a simple fix for it. It's called the capacitor crush mod. You take the top off the radio. You identify the components on the board. You take your trusty pliers and you crush the capacitors, depending ones. You flip the radio upside down, shake the pieces out, put the cover on it, you're done. Now you have a high end. You know, it was that simple. But the low end response lacked. Very simple. You could still use a soldering iron and change the components because they all had leads. Yeah. So you fatten up the coupling capacitors, and now you have something that actually is pretty decent response. Now, in the terms of the ICOM 735, they went about it a little differently. The audio of the 735 is extremely tin can, and if you look at the schematic, you'll see that on the input from the microphonium to the first stage, there's a tiny little value coupling capacitor, but there's another cap with a set of jumpers that you can solder together that'll increase the coupling and fill out the low end noticeably better. So it's like, okay, you open that up, and then you'll see these two little jumpers with a little solder blob on each one with yellow sleeving on them. Move them together, solder. And then you'll also see these other jumpers that I believe if you solder them together, then the radio becomes general coverage. Boy, I had a lot of fun on the Good Buddy band back in the 90s driving my 4400, that Class C plate modulator. You got the troglodyte on the channel, Cam-Ann. But that gets old after a while. But then we go to the Yaesu product. The older Yaesu hybrid gear, like the FT101B, E, and F, have what I call it bass modulation, where they modulate the bass of a buffer transistor. You have a CW oscillator transistor with a CW crystal. And the audio is mixed at that point, so you get AM, and then that's passed on down the line and out to the antenna. So if you look at the schematic, they have tiny little coupling capacitors. You have an FET front end on the first stage, so you greatly up the value of the resistor on the gate from 47K to 22 megohms, stick a D10-4 in front of it, and there you are. It really sounds tremendous. But the way D104s come from the factory, it's out of phase. So you just unsolder the leads on the back of the element, reverse them, you're good to go. But many years ago, I examined the schematic and saw what to do and did it, published an article on it. A lot of people have done it, but since then there's been a few upgrades and changes. But what it does is that turns the FT101E, B, or F into a fairly high performance transmitter when used on AM. Now the mods also cover improving the receiver audio. Well, unfortunately, the widest filter available was 6 kilohertz. In fact, International Radio, or INRAD as they call themselves, still sells the AM filter for the FT101. So the end result is an older style ricebox. My God, the 101E is almost 40 years old now. It's amazing that all those little Nipponese electrolytic capacitors and other components that are cheesy are still around to function rather than burn up or short out. Although the electrolytics and the power supply get rather tired, and the ones I hear on from time to time, you hear a little bit of 120 cycle or 60 cycle hum in there and whatnot, but it's all fixable. But as far as the newer rice boxes are concerned, one thing I find interesting is in the world of SDR. Now, the world of SDR, just about all of them are capable of nearly broadcast quality AM. The beginning was the Flex radio. The entry level, the Flex 1500, I think is only good to, I think, 3.2 or 3.8 kilohertz, but I understand that somebody has written some software that opens it up to where it's probably good to 10 kilohertz. The Flex 1000, the first of those series, 5,000?
Oh, 1,000.
The 1000, I think, was good to 10 kilohertz audio response. The Flex 5000 was probably the best sounding one of the lot. The intermediate price unit, the Flex 3000, with the first issue of software brick-walled at 3,800. And it would sometimes hiccup and drop out under modulation. It was always doing that. So new software was written. The high end goes up to 4.5 kilohertz, and it doesn't hiccup and drop out. The end result is 4.5 is close enough to 5 to where you can make that radio make damn good AM. So now the bar has been raised. You see, AM is not a plug and play thing like a lot of ham radio people expect it to be. You spend money, you buy a box, you bring it home, you look around out there in the commercial area and buy a bag antenna, throw up an antenna, barf it up in the trees, don't study the lengths of what it has to be. It's all made out of components that you can always buy at the hardware store. You can make your own insulators, hook the coax up, and you're good to go. Then you buy the radio, you plug it in, you use the microphonium that came with it. I don't know of any of those rice boxes that have what I would call a good microphonium. Some of them begin to approach something that may sound a bit reasonable, but by and large, they just don't measure up. So the microphonium is an important part of the equation where you don't have to spend a lot of money, like spend $200, $300, $400 for a high quality dynamic or what have you, because the radio will never, ever, ever have the capability of the frequency response that microphonium is capable of supplying. But if you go to a music shop and get a used Shure SM58, for instance, and a little preamp equalizer, and then feed that into what I call the back door, which is the accessory connector in the back of the radio, which accesses your receiver detector out, modulator input, etc. In some cases, you can bypass a number of the low-level stages that were the microphonium stages and the restrictions, but they change over time. Like you see with the ICOM 735, you can do that, and the results are not bad, because to properly do an ICOM 735, and I've done several, it's about 8 hours under a magnifying work light wearing reading glasses on top of it. And that was back when I was in my 40s. So I don't know how easily I'd be able to do it now. But basically, fatten up all the coupling capacitors, both in the receiver and the transmitter audio. And then when I swept it, the audio response on the test oscillator I had went down to 18 hertz. I used 400 hertz for my reference, went down to 18, flat. It looked like clinically perfect AM at 18 hertz. Then I went up and up and up. And then when I hit 7.5, it dropped. So that tells me the FM filter is permanently in the bandpass as a roofing filter. And there's nothing wrong with that. And the reports I get with the thing were tremendous. But I used to use it basically as an RF carrier exciter for the plate modulated 4400 transmitter. But from time to time, I use it as a standalone at about 10 watts. The other thing is about the 735 versus the 757 is on the back of each of the heat sink, there's a control marked AM carrier. So as it is, with the radio from the factory, it'd make 40 watts, maybe slightly more, and they had a little slide pot that you'd set your carrier, your output level. So you probably crank it all the way up. All that did is adjust the threshold of the ALC. So when you want to back it down to say 20 watts or whatever, now, you know, the positive peaks of your voice are constantly socking the ALC, and it clips and burps and farts even worse. You know, when you're trying to get away from the problem, it just gets worse. So in that case, with the AM carrier control, that probably sets the balance of the balance modulator in terms of the imbalance. So you back it down to about 20 watts with a slide pot up all the way. Now it cleans up. So it's just amazing. Whereas with a 757GX, what Yaesu did is they just stuck a pot in the line of the chain of RF amplifiers. So if you turned it down there, you legitimately backed off the carrier and got away from the ALC. But it's like an audio gain pot in an audio amplifier. You can feed a good healthy signal into, say, a lower level stage and be on the edge of clipping it and back the gain down because it's too loud. Or you reduce the level and turn the gain up. Well, with the 757, for instance, if you turn the RF power up all the way, you get a good fat 100 watts out before the pot is fully clockwise when on AM. But that too has got an AM carrier level in the heat sink. So you tweak it down to about 30 watts. And then you use the front power control to trim it back. That way, you've got a lot of headroom in the system. It's all about headroom, particularly in a linear amplified system. But I'm wondering where it's going, because ICOM now has come out with a new transceiver, the 7300, which is basically a standalone SDR radio. I've heard a few on AM, and they're quite restricted. And I don't know why that is. I was waiting in line trying to talk to a guy at the ICOM booth to ask him, all right, what is the total transmit bandwidth capability when on AM? And if it cannot measure up to a flex or an anon, then I was going to chastise them. I didn't get the opportunity to do that. So that's the story about rice boxes, and the story is a long one. It just goes on and on and on. I think it's a combination of what? People still use AM, or in engineering, in the engineering department, they say, well, our radio receives AM, let's see if we can make it transmit on AM. So they kind of, sort of, kind of do. But as to how well it works, I don't know. It's to be determined. And then I see them sliding backwards. For instance, ICON came out with a 706, which was a very interesting little radio. Really sounds tin can on AM, but it's effectively modulated. It's truly glass-cutting audio. Then later on, it was supplanted by the 7000, being that the 706 was dropped from production. The 7000 totally falls on its face when it's on AM. I've known a number of people to use them, and in many cases, the modulation is like a mother flea calling its young. So there you go.